Hi, my name is Katya Damsky,
I'm Katie Kennedy.
I'm Mari Pettingill.
And Nikolai Klein.
and today our group is going to be talking about seasonal variation in particulate organic nitrogen and phosphorus levels in relation to the Redfield ratio. The Redfield ratio, which is the ratio between carbon to nitrogen to phosphorus at 106 to 16 to 1 ratio, was established to explain the global oceanic stoichiometry and has been considered a standard since its creation. It is known that nutrients deviate from ocean to ocean, with the Atlantic having higher N/P ratios compared to the Pacific, which has lower and more steady ratios. Our study is observing if there are any seasonal changes in this N/P ratio by comparing 2 years using combined data to mimic a global setting. With constant nutrient inputs from anthropogenic sources, this can change the nutrient concentrations, so it needs to be updated accordingly.
For our methods, the data was collected from the Northwestern Atlantic and the tropical Pacific. Only the data from the top 200 meters of the data was used. All other data points were omitted. Water samples were collected using a Niskin bottle and filtered through a glass fiber filter for the particulate organic nitrogen, and the ash hydrolysis method was used for the particulate organic phosphorus. An ANOVA single factor test was separately used on the seasons for the 2003 and the 2007 data. Figure 1 is a complete global distribution of all the location sites and samples collected. Our study only looked at the 2003 and the 2007 data. So our data set only highlighted the Northwestern Atlantic and the tropical Pacific Ocean.
So what we found can be described in figure 2. And what we found is that most of the N/P ratios described were higher than the original Redfield ratio, and that spring had the highest means with the least variability. This plasticity could be due to deep water consistency and movement, but it could also be due to other things. The variability in limiting nutrients could also affect the stoichiometry in the phytoplankton biomass. Redfield himself did not actually take into account the biogeochemical processes in the oceans and the fluxes that happen on season to season, resulting in this seasonal variation. Other physical and chemical factors such as day length, salinity, and temperature are also ever changing and definitely need to be factored in when looking at this data. If we look back at figure 2, we can see that the blue line on our figure is that average N/P Redfield ratio. And it just highlights that our means were much higher, except for in fall of 2007, which was actually lower than the average Redfield ratio.
In conclusion, our results deviated from the Redfield ratio, showing that there's an increase ever since the original founding of the N/P ratios nearly a century ago. Due to seasonal inconsistencies in this study, it suggests that further research is required. The Redfield ratio needs to be reassessed and possibly adjusted to better fit these higher N/P ratios using more modern data. We would also like to thank Eckerd College for this opportunity to do this study, as well as Dr. Sweta and the other students for their editorial input, as well as Woodhold for the access to this data set.